In this video, we're going to use Cramer's rule to solve a system of 3 equations and 3 variables. They give us a system of equations with 3 variables, and we're going to use Cramer's rule to solve for x, y, and z. First thing we need to know is that x is going to equal dx divided by d, y is going to equal dy divided by d, and z is going to equal dz divided by d. And then we're going to need to figure out dx, dy, dz, and d. And to do that, we're going to use these little formulas. I'm going to kind of I'm going to put them on top of the problem. So it's going to say dx equals determinant of d1, d2, d3, b1, b2, b3, c1, c2, c3. Obviously, this is a1, b1, c1, then d1. Right, it would go in order, alphabetical order. So A, B, C, and D. And the 1s, 2s, and 3s just stand for first, second, and third equations. So let's start writing this out. This would be equal to the determinant of, so d1, d2, d3, that's going to be 3, 1, negative 1. And then b1, b2, b3, that's going to be 8, negative 2, and 2. And then c1, c2, and c3, that's going to be 2, 1, and 4. And then I'm going to actually add in, I would stop here and usually put a bracket, but because I know I'm going to find the determinant of this 3 by 3, I'm going to need to take column 1 and extend it right here. And I'm also going to do that same thing with column 2. So I'm going to write this as 3, 1, negative 1, and 8, negative 2, 2. So then we're going to go through and we're going to multiply these to find the determinant. So this is going to equal 3 times negative 2 times 4. So if I multiply that, 3 times negative 2 is negative 6 times 4 is negative 24. Then I'm going to add that with 8 times 1 times negative 1. That's going to be negative 8. So minus 8. And then I'm going to take 2 times 1 times 2, that's going to be 4, so plus 4. Then I'm going to subtract. We're going to start here in this corner. We're going to do 2 times negative 2 times negative 1. That would be positive 4. Then we're going to do 3 times 1 times 2. That's going to be positive 6. And then 8 times 1 times 4. That's going to be 32. Go ahead and add those together. Got negative 32 plus 4. I'm going to use a calculator to make sure I don't screw this up. This would be negative 28 minus 4 and 6 is 10. That's 42. Negative 28 minus 42 would be negative 70. So our dx value is going to be negative 70. I'm just going to kind of write those right here. Dx, negative 70. Now we got to figure out what dy is. So let's get rid of this one. I'm also going to get rid of these, so I just have a little bit more room. So dy is going to be the determinant of a1, a2, a3, which would be 5, negative 1, 1. D1, D2, D3, that's going to be 3, 1, negative 1. C1, C2, C3, that'll be 2, 1, and 4. And then we need to expand column 1 and column 2. So that'd be 5, negative 1, 1, and 3, 1, negative 1. Let's go ahead and start finding that determinant. We're going to take 5 times 1 times 4. That'd be 20. We're going to add it with 3 times 1 times 1. That's going to be 3. And then add it with 2 times negative 1 times negative 1. That's positive 2. Then we're going to subtract it from 2 times 1 times 1, which is 2. 5 times 1 times negative 1, that'll be minus 5. And then 3 times negative 1 times 4, well, you get 12, but that'll be a negative 12. So when you subtract those, you end up with 25 minus 2 minus 5 minus 12. That's a negative 17. So 2 minus 17, that'd be negative 15. So we're subtracting negative 15, which is really like adding there, so we end up with 40. So dy is 40. All right, now we're going to go and find dz. So dz is going to equal the determinant of a1, a2, a3. So that's 5, negative 1, 1. B1, B2, B3. So that's 8, negative 2, 2. And then D1, D2, D3. So that'd be 3, 1, negative 1. Let's expand column 1 and column 2. So that's 5, negative 1, 1, and 8, negative 2, 2. So this is going to equal 5 times negative 2 times negative 1. That's going to be positive 10. 8 times 1, positive 8. 3 times negative 1 times 2, minus 6. Subtract, we're going to go 3 times negative 2 times 1, that's negative 6. 5 times 1 times 2, that's positive 10. And then 8 times negative 1 times negative 1, that's plus 8. So we get 18 minus 6, which is 12, minus negative 6 plus 10 plus 8. That'd be 4 here, plus the 8, that's 12. So we get 12 minus 12, which is 0. So dz is 0. Now we're going to find d. That's the last piece that we need to get before we can find our solutions. So d is going to equal the determinant of a1, a2, a3, so 5, negative 1, 1. B1, B2, B3, 8, negative 2, 2. And C1, C2, C3, that's 2, 1, 4. And then let's expand column 1 and column 2. And when we do that, we get 5, -1, 1, and 8, -2, and 2. So this is going to equal 2 times -2 times 1. That's -4. 5 times 1 times 2. That's 10. 8 times -1 times 4. Minus 32. Minus, oh no, I did that backwards. Okay, so we're going to say that this should all actually be in this bracket, so we're just going to fix it quick. So we're going to have this minus here, bracket. This would be -4 plus 10 minus 32. That should be in this bracket here. We're going to cross this out. I should have went this direction first. So we're going to take 5 times -2 times 4. That's -40. 5 times 4 is 20. Times -2, -40. Then 8 times 1 times 1. That'd be plus 8. And then 2 times -1 times 2. That's -4. So you end up with -36 minus, if we add these together, that'd be -36 plus 10 would be -26. So it's -36 plus 26. So we should get -10. And that's what D would equal. So then we go through and we use this piece for the X, the Y, and the Z. And we know that X is going to equal dx over D. Y is going to equal dy over D. And Z is going to equal dz over D. So dx is -70 and D is -10. dy is 40 over -10. And dz is 0 over -10. And so we end up with x being 7, y being -4, and z being 0. So our coordinate there would be 7, -4, 0 for our solution.